Hello, PreCalc. See the snowflake on my teacup? Well, it just so happens that I'm sitting here on Saturday morning waiting for the snow or ice that we've been promised and deciding whether or not to go out to the movies and brave the weather. So before I go to La La Land, I'm going to put you into La La Land with a video review. All right. So this is after Friday the 13th class, and I'm sorry it should have been up after class right away, but it's Saturday already. Sorry I didn't get it up last night or the night before. I'm a little behind. We're reviewing in this video for our test preparation. We have a take-home test that is due on Friday, and that's the last day of the quarter. Sorry, I can't take it any later. So please have that, keep that in mind. And we have a deal. If you complete 4 on Tuesday and 4 on Wednesday and 4 on Thursday, that will give you 12 out of the 20 problems done, and you'll be just about 6 or 7 from finishing. Alright, so I might up that to 5. We'll see. Make sure you all don't wait to the last minute. Alright, here we are practicing product to sum and sum to product. So somewhere in your comp book, in one spot, and in your notes, you have all these in their glory. Alright, so when you start with a sum, go to the product. That's these right here. And then if you start with a product and want to write it as a sum, these right here. So it's pretty much, I remember when you did these, you blew through the assignment, so I'm not going to linger too long on those. So which one will help us with this problem? Cosine 5x, sine 4x, to write it as a sum. Alright, so obviously we're starting with a product, so we're going to start with the lower 4 and look for one that matches. Cosine, sine. So, tell me when. Okay. Alright, so this is the one. Good job, class. We're going to recognize that our u is 5x and our v is 4x. And we're just going to plug these values in as we go down the ID. So 1/2 sine, when I get to the u, I put it in a 5x. And then when I got to the plus v, and v I put in the 4x, minus sine, the u, again 5x, and the v 4x. Simplify a little bit. And the 5 and 4x become 9x, whereas the 5x and the minus 4x become x. And I guess you can leave it there, and I would give you full credit. And some of you would like to get rid of the brackets when you can, so you can multiply by 1/2 and get that is the more excellent answer. Alright, so that's that. And then going the other way, we have write this sum, write that. I don't need the equal 0 part. Got carried away with myself here. Alright, too much tea, too much caffeine in my tea. Write that as a product. Alright, writing that as a product, we have sine of something plus sine of something. So we're up here in these IDs. So where is the right answer? Sine u plus sine v. Alright, it matches our problem. So our sine, this is our u this time, and this is our v. Alright. Following the formula above, can't show you both at once this time. Plugging in as directed, I got this. 2 sine 5x plus 3x over 2 cosine 5x minus 3x over 2. So this became 8x over 2, and this became 2x over 2. Simplifying, you get 2 sine 4x cosine x. Alright, the only caution I want to use is sometimes these trig IDs, I don't think I did any more of these kind. Sometimes these trig IDs, when you do what these formulas require, sometimes you'll come up with sine of, say, negative 4x. If that happens, you can simplify it further. We had a trig ID that allowed the negative sign to come out of the argument and go out in front. So, and do you recall what happens when the cosine of the argument is negative? Then, cosine of a negative argument. Then it actually can be dropped because cosine is an even function. Alright, so I will mention that those situations did not come up in these examples, but keep that in mind. Alright, then we jumped into vector land and we learned how to write vectors. We'll start, let me cover some of this so you're not overwhelmed and fainting. Alright, the component form, here is the component form. Negative 3i plus 4j describes a vector, and another way we wrote that is with the pointy parentheses. Alright, these are identical in information, different forms. Let's graph either one, be prepared to graph either one. And it says we go negative 4 on the I direction, and we're in the real plane now. This is nothing imaginary. So this is the x-axis and this is the y. So we graph the x's on the i's are on the x-axis, the j's are on the y. So we went back 3 and up 4, indicated by those numbers. So the point described here is right there. And all right, so the vector goes from the origin to that point. So that vector is described here. It could be over here, and it could be down here. So if you knew this point, and it wasn't here in standard form, you would subtract the x values and subtract the y values to get this j part and this I part. Alright. Alright, I want to find the magnitude and direction, so let's move this to standard form again to see clearly the negative 3 and the 4. Magnitude is this value, and we find it by Pythagorean theorem, and the direction would be this value, the angle of this vector, and that is inverse tan, the y value over the x. Alright, so here I Pythagored it, and I got an even number, 5. Square roots are welcome. All square roots are welcome as magnitudes. And I don't think I did the direction. So let me do it now. I'll have to run for my calculator. So tan inverse of the y value over the x value will give me the direction. Alright, inverse tan, and I'm putting in 4 divided by negative 3, enter. Alright, it's giving me a minus 53, which is kind of a bogus answer. So I remember my inverse adjustment map. When it's in the second quadrant, we're going to add 180. So adding 180 to that, I get 127. So plus 180 equals 127. Alright, so that is the magnitude and the direction. Alright. Let's look at the complex plane. Again, I emphasize we were in the real plane there. On the complex plane, we get values like this. No pointy box, no pointy parentheses. just forms like this, where we have A plus or minus BI. That's the form, you know you're in the complex plane. There's no J, and there's one I winking at you. So, graph it. So I went over 5. Remember, the real parts are graphed on the x-axis, and the imaginary parts are graphed on the y. So we went over 5 and down 3. All right, I'll write that in. So that point has been graphed. I'm going to complete the graph by putting in those lines. And there's another form, and it's called Trig Form. In Trig Form, first of all, we need the magnitude again. So some students grab the I. There is an I next to this number, but to get this value, we do not need the I. So we're just going to, everyone knows this value is on the I-axis and represents minus 3i. But to get this value, do not include the I. So the square root of 5 squared plus minus 3 squared is 25 plus 9, which is 34, square root. Square root of 34. Square root's welcome. And then trig form always looks like this. Magnitude, parentheses, cosine, some angle, plus I sine the same angle, close parentheses. To find what this angle is, we are going to do an inverse tan. Again, it's going to be the vertical part, which in this plane, it's the I imaginary side, divided by the real side. Always vertical by horizontal. And when I did that, I got nothing. Okay, let me get my calculator out and do that. Inverse tan. It's funny, I remember doing that. It's clear as a bell. I think there's a few bats in my belfry. All right, so we have minus 3 over 5 inverse tan, which I'm putting into the calculator here. Doesn't show up very well. And enter, and I get minus 30. Can't see it. Pull out your Dramamine. I'm taking you on a ride here. Bumpy ride. It's going to be a bumpy ride. We'll say minus 31. All right, bogus answer. How do we adjust for a minus 31? Well, we see we're in the fourth quadrant, and the inverse tan map is you add 360. So without showing you, I'm going to add 360 and get 329. So in the positive direction, it's 329. So that goes in here. These can be degrees or radians. All right. So that's trig form for this number, which is what we call standard form. To multiply numbers that are in trig form, we found a rule that worked well and proved why that worked, or showed why it worked at least. So here's one complex number in trig form, and here's the other. The little dot means we're multiplying them. And someone noticed that you multiply the magnitudes and add the angles. So I'm not talking about adding this angle with this one. These are always the same. It's going to be the angle in this trig form with the angle in this trig number in trig form. So to do that, I get square root of 55, cosine pi over 4 and pi over 2 add up to 3 pi over 4. So that's the answer. If you're asked to go back to standard form, you simply look on the unit circle, find cosine of 3 pi over 4, and multiply square root of 5 to it. To divide, if we have this complex number divided by this complex number, we divide the magnitudes and subtract the angles. So dividing, we'll simplify that in a second. 7 square roots of 2 over 14. Adding this, subtracting, starting with the top and subtracting the bottom. Simplifying that. The 7 and the 14 simplify. Square root of 2 unchanged. So we have minus 2 over 3 when we reduce. And using the trig idea mentioned earlier, when you have a negative in the argument of a cosine, it can be dropped. I have a video on why that's true. Feel free to refresh your memory. And this negative sign cannot be dropped, but it can come out in front when it's paired with a sign of a negative argument. So that is how you divide. All right, I'll review a little more on Tuesday night's video, but that'll be the end of our review, and we'll be learning some new, we're actually done trig, so we'll be learning some new math come Wednesday in class. So it'll be Tuesday night our review, and then Wednesday night will be our new beginnings. All right, so have a good long weekend, not a long break, but a long weekend. And I hope it gives you some refreshment, and I'll see you on Tuesday morning. Bye.